Let's practice using our unit circle now to find these exact values of these angles down here. Alright, so we just want to practice sine and cosine, and then I'm going to, after we do sine and tangent here, I'm going to ask you immediately, alright, well, what's the cosecant of this? What's the cotangent of this based on what we get for this? Now, right now, remember, 2 pi over 3. That's a negative value. So here's the unit circle. Alright, and then remember this was pi over 6, pi over 4, the things from the unit circle that we studied in the last section. So we had those 3 values in each quadrant. And if you remember going positive, this was pi over 6, pi over 4, pi over 3, that was pi over 2, and then this is pi over 2 plus pi over 6, right? Because pi over 6 is the first angle every time we rotate off of an x or y axis, positive or negative. So we always start off with pi over 6. So this is pi over 2 plus pi over 6. And remember, if you want to find out what that would be, just leave off the pi. So pi over 2, write that as 1/2. All right, replacing the pi with a 1, plus pi over 6, so 1/6. All right, and then change that to a fraction. And there's our 2 pi over 3. So in the positive direction, that right there is 2 pi over 3. Okay, but this is negative 2 pi over 3. So instead of going from here, 1, 2, 3, 4, 5 special angles to here, we're actually going in the other direction. We're going down because it's a negative angle. Remember, that means we're going clockwise. So 1, 2, 3, 4, 5, we're going down to here. All right, and notice we end up at the same position, just the opposite y coordinate. So what we find out with negative angles, if it's a negative angle going in there, it's the same thing as the opposite of the sine of the positive version of that angle. And that'll always be true. If you have a negative angle in there for sine, you can pull that negative sign on the outside and just find the positive version of the sine of that angle, because sine is the y coordinate and we're rotating down instead of up. And remember, if you rotate down, the y values are initially negative. If you rotate up, the y values are initially positive, and because it's a circle, there's symmetry there for those y coordinates. Alright, now the sine of 2 pi over 3. The way I remember this, the special values going along on the unit circle, the special values you see are going to be 1/2, square root of 2 over 2, and the square root of 3 over 2. Right? And the easy pattern there is 1 is the square root of 1. Right? The square root of 1 is 1, so you can really just kind of think of it as square root of 1, square root of 2, square root of 3, all over 2. Right? And remember, just like with numbers, 1, 2, 3, they're getting bigger. The square root of 1, the square root of 2, the square root of 3 are also getting bigger. So this is the largest, this is the medium one, this is the smallest. Alright, so sine is the y coordinate. Alright, the y coordinate is the highest of these 3. So it's the square root of 3 over 2 for this one. Alright, where the y coordinate is going up this way, and of these 3 special angles, the intermediate ones between the axes, this has got the highest y coordinate, so that means it's going to be the square root of 3 over 2. Okay, but remember, we rotated this way, we rotated down, so this will end up being the negative square root of 3 over 2. Alright, now, same thing for tangent, 11 pi over 6. So this time we're going to go down again, and remember, this is pi over 6, pi over 4, pi over 3, and we're going to go all the way around. But remember, this is 11 pi over 6. If you remember, all the way around one trip was 2 pi, and remember that rotating up was pi over 6. So 2 pi minus pi over 6, that's 12 pi over 6. Remember, 2 pi is the same thing as 12 pi over 6 minus pi over 6, which is 11 pi over 6. So in the positive direction, that number right there, rotating to that value right there, that's 11 pi over 6. But because we're going the opposite direction, we're going this way, we would actually end up right there. That's negative 11 pi over 6. All right, it's just underneath, going all the way around. It's the last special angle going back the other way. All right, now the tangent. Remember, the tangent is the slope of this line segment that's connecting the origin to that point. So, or you can think of it as just the y coordinate divided by the x coordinate. The y value, if you think about how we did it before, the y value here is the lowest of those three special values. The 1, square root of 2, square root of 3. Remember, that's the values for either x or y in these three positions. So the lowest y, because it's the lowest, the smallest height at this point, so is the 1/2. So that's our y coordinate. And then the x coordinate, guys, because we need to do, for tangent, we need to do y over x. The x coordinate, at this point, we are the longest of those special three. All right, we're the farthest away from the origin, left to right. So the x coordinate is, again, how far left or right we're going. And this is the farthest away we could be without being all the way at 1. So there's, the square root of 3 over 2. There's the square root of 2 over 2 for x. And there's the 1/2 for x. Okay, so these are getting bigger. So the biggest x is right here. The smallest x is right here. The biggest y is right here. All right, the smallest y is right here. So it's the smallest y and it's the biggest x. Okay, so this is our y coordinate. This is our x coordinate. All right. Now it's a fraction. It's the tangent is y over x. So it's 1/2 over the square root of 3 over 2. All right. That's a fraction divided by a fraction. If you write it left to right, you can this divided by this, and I would flip that and multiply. So I end up with 2 over the square root of 3 because we're dividing by a fraction. We flip and multiply, the 2's cancel, and we end up with 1 over the square root of 3 is the value of the tangent of 11 pi over 6. Now, you can check that with your calculator. All right, make sure, because when you see pi with those those angle measures inside of the tangent and the sine and the cosine, remember those are radian measures. So make sure you're back in radian mode, and then tangent of negative 11 pi over 6, and get that decimal. It's going to be a decimal. All right, and then plug in 1 divided by the square root of 3 and verify that you get the same thing. So that way you kind of know that you did it right. Okay, so there's the same thing. Now, just to kind of give you an idea, a heads up, y over x is what we're going to get for tangent. So here we saw that it's 1 over the square root of 3. Here at 45 degrees, remember at 45 degrees, the y coordinate and x coordinate are the same. We're the same. We're in the middle value for both. We're the middle of the 3 possible x values. We're in the middle of the 3 possible y values. So they're both the square root of 2 over 2. So y divided by x in that case is going to be just 1. So the tangent of pi over 4, or 45 degrees, is 1. And again, you're on your line y equals x when you're at 45 degrees. So the slope is 1. Well, then if you're at the highest one, now the y value is as high as it can be, and the x value is as short as it can be. When I say short and high as it can be, I mean of these three. So it kind of is like a role reversal. The y gets to be the square root of 3 over 2, and the x gets to be the 1/2. And in that case, we end up with the square root of 3 over 2 times 2 over 1. All right, and we end up with the reciprocal of this, just the square root of 3 over 1, or just the square root of 3. So that's not a bad thing to have on your a unit circle if you make a unit circle. As well is the values, not just of x and y, but the values of sine and cosine. So if you do a Google search for unit circle, you'll get things like this. And let me click on that. So you get things like this that have the degree measure, the radian measure, and then it has the x, y coordinate of those points. Well, remember, that's cosine and sine. So the cosine of 30 degrees is the square root of 3 over 2. The sine of 3 pi over 4 is the square root of 2 over 2. Right, but that's what I was talking about before, is it's always going to be square root of 3 over 2, square root of 2 over 2, or 1 over 2 for all these values. And notice this is 3, 2, 1, 1, 2, 3, 1, 2, 3, 3, 2, 1. It's just, it has that pattern over and over again. But because it's that pattern over and over again, the y is just, or sorry, the tangent is just y over x. You always get that same pattern for tangent. So it's not a bad idea when you search for one of these and print one of these out. I'd go ahead and print one out to have access to it. But just use the fact that the tangent here, that's not a very steep line. The tangent here was 1 over the square root of 3, we just saw. All right, the slope here was 1. Okay, and then the slope here, this steep line right here, is the square root of 3. Okay, so because these things flip from 30 degrees to 60 degrees, the y-coordinate becomes the x-coordinate, the x-coordinate becomes the y-coordinate. We just get a reciprocal because the tangent is y over x. And then here in the middle, it's always 1. And then over here in the quadrant 2, you're going to get -1 for tangent. Here, this is the steep slope, right? It's kind of the mirror image of that. So we get a negative square root of 3. That's steeper than 1 over the square root of 3. So that means this one is -1 over the square root of 3. All right. So there's a pattern with the sines and cosines. That makes for a pattern with the tangents. All these on the outside here are the tangents of the angles. These first values are the cosines of the angles, comma, and these second values are the sines of the angles. So all the points that are given you on the unit circles are sines and cosines. And then if we divide the y-coordinate by the x-coordinate, we're always going to get these all the way around, right? Positive or negative, okay, based on the sines and cosines, because it's division. Negative divided by negative is positive, so we'll get positive tangents. All right, positive divided by negative is a negative, we'll get negative tangents. But notice this line right here is also the same as this line right here. It just comes straight through. So the tangent is the slope of that line. It's the same line on both sides, so the tangent here is also going to be -1 over the square root of 3. Okay, and you can just use that property to find out all of these different values for sine, cosine, and tangent. So a really great idea, just to Google search unit circle and then print one of these out. Have it with you when you're doing your homework, because you're going to need to know what is the sine of pi over 2. There it is. What is the cosine of 5 pi over 6? Cosine's the x-coordinate, so there it is. What's the tangent of 11 pi over 6? There it is. All right. So the unit circle, there's a lot of patterns to it. There's a lot of symmetry there, and it's basically getting this first quadrant down. And then once you have the first quadrant down, just thinking about the signs, not sine, but the signs of the numbers that would be in each quadrant, and that'll get all your values along with their signs correct.